Hello guys, I hope everything is going well for you all. Today in this video we'll try to solve one of the hardest problems asked during coding interviews, the median of two sorted arrays. So let's get started by reading the problem and try to find the solution. So the question is given two sorted arrays nums1 and nums2 of size m and n respectively. Return the median of the two sorted arrays. The overall runtime complexity should be O of log m plus n. So what do we mean by median? Median is the middle number, and the middle number is determined by sorting all data points and selecting the middle one. Or if there are two middle numbers, taking the mean of those two numbers. Example, the median of 3 and 2 and 1 is 2, because when the numbers are put in order, 1, 2, 3, the number 2 is the middle. So the first solution to this problem is going to be by creating a list containing numbers from both lists and then finding the median numbers. Therefore, we will create an empty list that keeps the value in increasing order. And given that the input lists are sorted, we will need to compare only the first element of each list and repeat the operation until both lists are empty. After that, we can find the median. If the length of the new list, which holds all the numbers, are odd, the median is in the middle. If the length of the new list is even, the median is the mean of the two middle elements in the list. So the first solution for time complexity is going to be O of max n or m, where n is the size of nums1, the list 1, and m is the size of the list 2, nums2. And the space complexity is going to be O of m plus n, because we are creating a new list that includes the two lists. However, what if the interviewer asks you to reduce the time and space complexity? The first thing we're going to do is to check if the two lists are sorted. Yes, that's true. And we know that when we find the median, everything at the left is smaller and everything at the right is bigger. And if we apply the same logic to the two lists, we must find a separation such that the number from both lists to the left of the separation is lower, while the number from the list to the right of the separation is larger. To solve this problem, we use binary search to determine the proper division since both lists are sorted. And binary search, also known as a half interval search or logarithm search. So our logarithm is going to be, first, the size of list 1 should be less than the list 2. If the condition is not true, list 1 and list 2 should be switched. And we need two variables, start and end, to track the start and finish of our list, means the smaller list. The median is the point that will divide the sorted merged arrays into two equal pairs. So the actual median point in the merged arrays will have been m plus n plus 1 divided by 2. We'll run a loop until start is less than or equal to, and we will have two variables that determine the division on both the lists. The first one gonna be division 1, which is equal to the middle of the smaller list 1. The second one gonna be the length of list 1 plus the length of the list 2 divided by 2 minus division 1, which is the middle. And the median is the point that will divide the sorted merged arrays into two equal parts. Then we start checking for the left and the right of the median at each list. When there is nothing on the left side, then we assign infinity. I mean, the left division is going to be infinity. After we find the correct partition, we will have 4 numbers, and those numbers must respect those conditions. The left division 1 must be less than the right division 2, and the left division 2 must be less than the right division 1. And after that, we check if the length of both lists are even or odd. I know, guys, it's a little bit confusing, but if you watch the animation at slow, you can slow the video and watch the animation and repeat watching the animation. You're gonna start seeing what I try to explain to you. And for the second solution, the time complexity is going to be O of log n, and the space complexity is going to be O of 1.